Alright, welcome to the experiment on determining the equilibrium constant for the reaction of iron nitrate with potassium thiocyanate to form iron thiocyanate. So the reaction or equilibrium we're going to be looking at today is iron 3 plus thiocyanate in equilibrium with iron thiocyanate. So we want to determine the equilibrium constant for this reaction. So to do that, our K value is going to be equal to the equilibrium concentrations of iron thiocyanate all over the equilibrium concentration of the iron ion and the thiocyanate. The problem with equilibrium concentrations is they're very difficult to measure because they're in situ or they're in the reaction, and if you want to measure the concentration, you can't actually change the equilibrium. And a lot of the techniques we know for isolating and determining concentrations would change around these concentrations. So what we're going to do is we're going to use spectrometry to figure out what the concentration of iron thiocyanate is in solution. So the way this works is iron 3 plus in solution is colorless, thiocyanate is colorless, iron thiocyanate is a red-brown color. So that means iron thiocyanate is absorbing some wavelengths of light in the visible region. So what we can use is, we're going to use a spectrometer. We're going to take a sample of this reaction, we're going to put some light in, and we're going to measure how much light comes out at a wavelength that's in the visible region. Now what happens is, absorbance, which is how much light is absorbed by a sample, is directly proportional to the concentration. So in this experiment, we're going to be looking at the absorbance being proportional to the concentration of iron thiocyanate. Now whenever we make a proportionality between the two, we have to figure out, well, how strong is that proportionality, or if we put in so much light, how much of it is going to be absorbed. So in this case, we need to figure out the absorbance is equal to some constant, I'll write it out. So this is our proportionality constant times the concentration of iron thiocyanate. So we don't know what this constant is, and that's what we're going to figure out. How strongly does the iron thiocyanate absorb? Okay? If we know that, if we know this constant, and we know absorbances, we can figure out concentrations or any of those combinations. So what we're going to do in this experiment, and specifically part A, is we need to figure out what a concentration of iron thiocyanate is, or we need to make a concentration of iron thiocyanate. So in the first part of the experiment, we're going to put a huge excess of iron 3 plus and with a very, very small amount of thiocyanate. Effectively what that's going to do is shift this equilibrium all the way to the right so that we can make the assumption whatever thiocyanate we put into solution completely reacts, and that now becomes the concentration of iron thiocyanate. So we know the concentration of the iron thiocyanate. If we put it in the spectrometer, we can measure the absorbance. So we have absorbance, we have concentration of iron thiocyanate. We can figure out what this proportionality constant is. When we get to part B, we're not going to make the assumption that the equilibrium is shifted all the way to the right-hand side. What's going to happen in part B is we're going to establish some equilibrium based on approximately equal concentrations of iron 3 plus and thiocyanate. So in that case, we can't make any assumptions about what our concentration of iron thiocyanate is. So we measure the absorbance in that case by knowing our proportionality constant. It'll let us know what the equilibrium concentration of iron thiocyanate is. If we know the equilibrium concentration of iron thiocyanate, and we know the initial concentration that we started of iron 3 plus and of thiocyanate, we can then calculate the equilibrium concentrations of all three species and calculate what our equilibrium constant is. So let's get over, we're going to start the experiment. So now we're going to start the experimental for the iron thiocyanate equilibrium experiment. It's relatively easy experimental. One of the big things you need to be careful with when you're getting going is you're using two concentrations of iron nitrate. In part A, you're using a 0.2 molar solution of iron nitrate. You're using a really, really high concentration because that's when we want to shift the equilibrium all the way to the right-hand side relative to the potassium thiocyanate. In the second part of the experiment, you're going to be using 0.002 mole of iron nitrate. Okay, so make sure you have those well labeled and you get them at the right times and you're using them in the appropriate places. Nothing worse than making all of your samples and then realizing you have the wrong concentration. So I've got everything set up here. What I've done is I've cleaned out some burettes and I put some solutions into them. Over here I have my low concentration of iron nitrate. I've got my low concentration, you're only using one concentration, but the low concentration of potassium thiocyanate, and I have some water. In my beaker here, I've got a high concentration of iron nitrate, so 0.2 mole. And I'm going to be using a lot of this relative to the other ones. So I'm going to start with part A. What I have is 3 volumetric flasks. And I'm going to start allocating 1, 2, and 3 mils to each one of them for the potassium thiocyanate. So I'm going to take this, take a measurement, and with the burette, put 1 milliliter in. Take the second one, I'm going to put 2 milliliters in. 1 milliliter, 2. And to the third one, I'm going to put in 3 milliliters. So I have my 3 milliliters. So I've got 1, 2, and 3 milliliters. Now what I want to do is, that's my potassium thiocyanate. I want to fill the rest of the volumetric flask up with just pure concentrated iron nitrate. So I'm going to take one of my funnels, and I've got my beaker, and I'm going to slowly pour in the iron nitrate. Now there's a line that marks 50 milliliters. You want to have an exact concentration. When you get close to the top, you're going to want to pull the funnel out, and I want to get right up to the top to make sure the concentration is accurate. I can use a pipette and a ball and just slowly start dropping in the rest until I get right up to that line. Probably take about 4 pipettefuls. And there. I've added the appropriate amount. Put a top on. Give it a nice little shake to make sure it's well mixed. And I have my first sample made. I'm going to do this again with the next 2 samples. What you're going to notice is, when you do this, you're going to get a very, very nice gradient. Okay? If you use the appropriate concentration of iron nitrate, the 1 mil is going to be very light, and you're going to go to fairly dark, and you go to really dark. You're going to see a nice gradient of colors. If you use the wrong concentration of iron nitrate, you're going to see very, very low or very, very subtle colors each time, so they're not going to be very bright. They're going to be about the same. So that's a good indication that you may have used the wrong concentrations, which happens a fair amount. So we have our samples here now. What we want to do is we want to measure the absorbance of them. So I'm going to take my sample here. We're just going to be using small test tubes as cuvettes, so a cuvette being the medium by which we're going to measure it. So what I'm going to do is I'm going to take a little bit of my sample, pour it into one of the little test tubes. Sometimes they're hard to pour. If they're hard to pour, you can pipette it out. I actually want to rinse this out first because I didn't know what was in here beforehand. It's best to rinse it with a bit of the solution. So I've got lots of it. Take a little bit, rinse it out, put it in my waste beaker, and I'm going to fill it up about 3/4 of the way with my sample. I'm going to take Kim wipe, give it a nice little gentle wipe down. Come over to the spectrometer. The spectrometer should be on. Make sure you have it on the right reading. We're reading absorbance, not percent transmittance. It should be at a wavelength of 447 nanometers. Open the spectrometer. You can see over here. Got a place we can just slide in our sample. Turn it down, and we're going to get a reading of what the absorbance is. It's not on right now, but when you put it on, you'll get an automatic reading. So you'll do that for all 3 of your samples in part A. After that point, you're going to plot a graph of absorbance of your iron thiocyanate against the concentration, which you'll calculate. You don't necessarily have to do that in the lab. Just make sure you look at your data and it looks like a nice linear trend. Your TA should be able to help you out with that if you're unsure if your data is correct or not. Okay? So once you've done that, you can move on to part B. So this is where the data we're going to be using to actually calculate the equilibrium constant for iron thiocyanate. So what we're going to do is we're going to take 5 test tubes. We're going to do 5 different trials. And in each one of these cases, we're going to be taking our low concentration of iron nitrate, or potassium thiocyanate in water, and we're going to be mixing up all three. We're going to add maybe 1 mil this time, 2 mils, 5 mils, and we're going to mix each one up. We're going to do 5 different samples. So we're going to come over here. What we're going to do is we're going to take whatever trial 1 tells us to do. Let's say it happens to be 1 milliliter of this. Then we're going to take 1 mil of this. And we typically go to the end with our water, so we're going to fill this up to a total of 10 mils, so we're probably going to put 8 mils of water in. Shake it up a little bit so it stirs. So now we have our first sample made for part B. We're going to take one of our cuvettes again, do the exact same process. Pour a little bit in, give it a nice little quick rinse. Pour the rest in, fill it up. Almost to the top. Should have had more. I didn't actually use the exact amount, so it should be a little bit higher than that. You should have plenty when you're doing this part of this experiment, given the amount you're using based on the lab manual. You can come back over and you can read your read the absorbance based on the spectrometer. From that concentration now, we're measuring the in situ concentration of the iron thiocyanate. You can work backwards and figure out what the equilibrium concentrations of all of your species in solution are and calculate what the equilibrium constant is. This experiment you're actually going to take home. So what you want to do is, one, you want to make sure you have your TA sign off on your data. Easiest thing is actually just give your TA one set of your data before you leave. That way they have it. You're going to take it home. The purpose of taking it home is not because we want you to write up an extremely long experiment. This experiment and the calculations take a bit of time. So you can take it home. You can put the data into a spreadsheet if you'd like. You can use a spreadsheet to calculate it. We want you to make a nice report. Now, nice does not mean long. It just means well written, easy to understand. Everything's correct in it. Make it look presentable. Make it nice. Make sure all the parts of the experiment are there. Title, purpose, procedure, data calculations, observations, conclusion. Okay. The discussion doesn't need to be extremely long, but it should center around some of the science going on here, what you figured out, how you did it, and of course a little discussion on the sources of error associated with this experiment.